Hello everyone, this is Sir Brian Cordova and welcome back to another calculus class. Our topic for today is differentiation rules of trigonometric functions. So itutuloy natin yung discussion about finding the derivatives. So for today, we have trigonometric functions naman. So number one, derivative of a sine function. So derivative of sine x is equal to cosine x. So as a proof, so if the function of x is equal to sine x, then getting the derivative or following the differentiation process, so we have the function sine of x plus h minus sine of x all over h. So taking the limit as h approaches 0, so that is the derivative. Recall lang natin that sine of x plus h using the angle sum identity, so sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. So this is yung mas tanda natin, tatawag natin sine of a plus, so sin cos cosine of alpha and beta. So we have the limit of yung angle sum would be sine x cosine h plus cosine x sine h. So sin cos cosine of x and h minus sine x all over h. Since the first and the last term ay may common factor na sine x, so let's factor them out. So sine x cosine h minus sine x. So sine x na yung lumabas, so factor of 1 na lang natitira. So cosine h minus 1 plus yung middle term is cosine x sine h, so all over h. This is equal to taking the limit of sine x cosine h minus 1 all over h. So yun na siya. Plus the limit of cosine x sine h over h. So both terms can have a denominator h. So let's recall the half angle identity. So sine of alpha over 2 is equal to square root of 1 minus cosine alpha over 2. This numerator can be 1 minus cosine alpha. So we have cosine h minus 1 is equivalent to negative of 1 minus cosine h. And 1 minus cosine h, so you can square both sides. So matitira is negative 1 minus cosine h over 2. And multiply natin yung 2 na yon doon sa kabila. Isama na natin yung negative. So we have negative 2 sine squared of h over 2 na yung nasa kabila. And remember that sine h over h, its limit is equivalent to 1. So we have times 1. So since this is square, so pwede natin ihiwalay yan. And yung factor na 2 is i-divide na natin sa h. So we have, so negative sine h over 2. So tinanggal natin yung isa para mawala yung square. So we have sine h over 2 na lang over h over 2. So yung 2 ron ay naging denominator ng denominator. So we have that one. And since sine h over h is equal to 1, so this one is also approaches 1. So plus cosine x. So we have the limit of sine x minus negative sine h over 2 plus cosine x. So and as h approaches 0, negative sine h over 2 approaches 0. So sine of 0 is 0. So we have sine x times 0 times 1 plus cosine x. So nakamultiply sa 0, so what will remain is cosine x. Thus, it is proved that derivative of sine x is equal to cosine x. Number 2, the derivative of cosine function. So proof, so if the function is equal to cosine x, then the derivative is equal to the limit of cosine of x plus h minus cosine x all over h as h approaches to 0. So recall natin, angle sum identity naman ng cosine is equal to cos cos sin sin, or cosine alpha cosine beta minus sine alpha sine beta. And pag expand natin, substituting the identity, we have cosine x cosine h minus sine x sine h minus cosine x. And yung first and last term has a common factor, cosine x. So what will remain is cosine h minus 1 minus sine x sine h over h. Okay, so taking the limit of this difference, we have the limit of cosine x cosine h minus 1 over h minus limit of sine x sine h over h. So recall lang natin that this has become 1 kapag kinuha natin yung limit, and this one approaches 0. So cosine x times 0 minus the limit of sine x, so sine x times 1. So what will remain? So this is 0 since naka-multiply sa 0. So what will remain is negative sine x. Thus, the derivative of cosine x is negative sine x. Examples. So find the derivative of cosine x sine x. So following the product rule, so recall lang natin that the derivative of the product u times v is equal to u times dv plus v du. So this is equivalent to cosine x, so yun yung u natin, times dv is derivative of your v, which is sine x, plus v sine x times du, or derivative of cosine x. So we have cosine x times cosine x, since the derivative of sine x is cosine x, plus derivative of cosine x is negative sine x. So cosine times cosine is cosine squared x minus sine squared x. Then number 2, find the derivative of 5x plus cosine x. So derivative of the sum. So derivative of 5x, yung first term, plus derivative of cosine x. So constant multiple. So we have 5, and the derivative of cosine is negative sine x. So we have 5 minus sine x. Number 3, find the derivative of cosine x over 1 minus sine x. So following the quotient rule, we have low, which is 1 minus sine x, the high, or derivative of the higher function. So derivative of cosine x minus high, which is cosine x, the low, which is derivative of 1 minus sine x, over low, 1 minus sine x squared. Okay, so we have derivative of cosine is negative sine. Derivative of 1 minus sine x is 0 minus cosine x. So distributing negative sine x and cosine x, we have negative sine x plus sine squared x plus cosine squared x. And sine squared x plus cosine squared x is equivalent to 1. So we have 1 minus sine x over 1 minus sine x quantity squared. So we can cancel out the squared, and what will remain is 1 over 1 minus sine x. Other trigonometric functions. So remember that derivative of sine x is equal to cosine x, and the derivative of cosine x is equal to negative sine x. So the derivative of tangent x is equal to secant squared x. Derivative of cotangent x is equal to negative cosecant squared x. Derivative of secant x is equal to secant x tangent x. And derivative of cosecant x is equal to negative cosecant x cotangent x. So to prove these derivatives of other trigonometric functions, we need to recall that tangent theta is equal to sine theta over cosine theta. Pag sinubstitute natin yung sine over cosine, so perform quotient rule. And cotangent is equal to cosine theta over sine theta. So perform quotient rule also. So secant theta is equal to 1 over cosine theta. And cosecant theta is equal to 1 over sine theta. Same process. Okay. So tips in finding the derivatives of the trigonometric functions, it is mostly easier to convert the functions in terms of sine and cosine only, since sine and cosine are the most basic trigonometric functions. So mas madali makahanap ng pwede i-cancel or i-simplify when in terms of sine and cosine only. So let's have an example. Now number 1, find the derivative of sine x plus cosine x times secant x. So we can do product rule. Sine x plus cosine x times the derivative of secant x plus secant x times the derivative of sine x plus cosine x. So we have the derivative of secant is secant x tangent x, and the derivative of sine x plus cosine x is cosine x minus sine x. So derivative of the sum is derivative of each terms. Now we can simplify each trigonometric functions into sine cosine functions only. So we have secant x is 1 over cosine, and tangent x is sine x over cosine x. Secant 1 over cosine. Okay, so now let's simplify. So we have sine x times sine x over cosine squared x plus cosine, maka-cancel out yung isang cosine dito. So what will remain for the second term is sine x over cosine x only. Plus 1 over cosine times cosine x, so magka-cancel out. And minus sine x over cosine x. So 1 minus sine x over cosine x na lang. So we have plus sine x over cosine x minus sine x over cosine x. So we can cancel this out. So what will remain is sine squared x over cosine squared x is actually equal to tangent squared x. So tangent squared x plus 1. And tangent squared x plus 1 is equal to secant squared x because of the one of the Pythagorean identities. So the Pythagorean identity, tangent squared x plus 1 is equal to secant squared x. Number 2, find the derivative of x, secant x plus 1 over x. So since sum siya, we can have derivative of each term. So derivative of x times secant x plus derivative of 1 over x. So derivative of 1 over x is, nakuha na natin yan nakaraan. We have 1 over negative x squared. And sa first term, we can use product rule. So we have x times derivative of secant x plus secant x derivative of x minus yung 1 over x squared. So derivative of secant is secant x tangent x. And derivative of x is 1 since it is derivative of the identity function, so 1. So simplifying, we have x secant x tangent x plus secant x minus 1 over x squared. So hindi na natin ma-evaluate yan. Kahit pa i-change natin into sine and cosine functions, wala na tayong makakancel because secant is 1 over cosine and tangent is sine over cosine. So we can't cancel anything. Number 3, find y prime if y is equal to 1 plus cosecant t over 1 minus cosecant t. So the derivative is y prime. So from here, we can simplify this by changing the trigonometric function into sine and cosine only. So cosecant t is equal to 1 over sine t. So 1 plus 1 over sine t, then 1 minus 1 over sine t. So simplifying that, we have sine t times 1 plus 1 over sine t. Same with the denominator, minus nga lang. So we can cancel sine t over sine t. Okay, so what will remain is sine t plus 1 over sine t minus 1. Now we can find the derivative of this function. So y prime is, so using the quotient rule, we have sine t minus 1 times the derivative of the numerator, sine t plus 1, minus numerator, sine t plus 1 times the derivative of the denominator, sine t minus 1, over square of sine t minus 1. So we have derivative of 1 is 0, and derivative of sine t is cosine t. So same ways dito. So we have derivative of sine t is cosine t. So we have sine t minus 1 cosine t minus sine t plus 1 cosine t. And yung denominator would be sine squared t minus 2 sine t plus 1. So factoring out cosine t, we have sine t minus 1 minus sine t minus 1. So sine t minus sine t is 0. So negative 1 minus 1 is negative 2. So cosine t times negative 2 over yung denominator. So yung denominator is change back lang natin into square since mas maikli siya. So wala naman tayo na i-cancel out na iba. So that's the simplified form. And thank you.